Let's do it. Pre-calc B, hopefully the final stretch. Using a polar grid, plot the given points. So remember, generally speaking, r theta. So this is the length of my radius. That's how far I spin it. So we're going to go, this is, I'm assuming 1, 2, 3, 4, 5. And so I've got a spinner 2 units long. I got to go up. Pi over 3 is 60. 60 times 2 is 120. And actually they got it listed right here, so I didn't need to do that. So that rotates all the way to here, and that is point A. All right, -1. Well, remember, that's the same thing as 1 pi over 6, polar opposite. So we got to figure out what that is. So we got 1. Pi over 6 is here, but that negative makes us go polar opposite. So there's point B. This one, 4 pi over 3 is, well, maybe it's listed. It's right here. All right. So we got spinner's 4 units long. I got to spin it until I get to here. So we spin it all the way to here. So there's C. All right. So this one, just got to imagine this. That's a 4. All right. And we got 7 pi over 4 right here. So my spinner's 3 units long. Spin it all the way to 7 pi over 4. But then I got to go polar opposite, which would be right here. Let's make sure I did that right. This is where my eyes start playing games on me. So, yep. All right, we got it. So that is point D. This one just means down 45. So my spinner's 5 units long. I got to go down 45. Which I believe this is, yeah. So if this is 315, which it is, 7 times 45, that means down 45, so that'd be right there. And that is point E. And then finally, I got to go down 5 pi over 6, which is down 150 degrees, and my spinner's 2, but then I got to go polar opposite. So 2, and then I got to go 90 plus 60. So I know this is 30 from here to here, so 60 would be here. Did I go 2? Yeah, so 2 right there. But then I got to go polar opposite, which would take me right there. So there's point F. There we go, plotting a bunch of points. Not bad. State 2 other ways to write the given polar point in polar coordinates radians. So, all right, we got to pay attention to the instructions. So the first thing I would recommend is just kind of getting an idea of where this plots us. So our spinner is, our radius is 6 units long. Our theta is 135. So that would put us right here. So I'm going to put a point right there. And so I know this is, we better stick with radians, 3 pi over 4, 6. So our spinner's 6, 3 pi over 4. We got to go 2 other ways. Well, an easy way to do it would just say go the other way. So a spinner's still 6. But now we need to go down whatever that is. Well, the easiest way to figure this out, and again, if this is 3 pi over 4, this is a little pi over 4 chunk. This is 2 pi over 4s, 4 pi over 4s, 5 pi over 4. So 5 pi over 4. And then we got to end up over here with a negative r going polar opposite. So I'm going to go negative 45. So it's going to be negative pi over 4, and then my r radius is 6, but it needs to be negative. So if I went down, and my spinner's still 6, and that takes me to the opposite side, it would take me right to here. So this one and this one are my 2 additional polar coordinates. Let's try it for this one. So my spinner's 1 unit long. I'm just going to make it big. And I need to go 5 pi over 3, which to get a general idea of what that is, it's 5 times 60, which is 300. So I'd spin it all the way to right about there, and maybe label it 5 pi over 6 equals 300, just so we can wrap our brain around it multiple ways. We know that this is 60, which is pi over 3. That's what's left. So that's one way we could do this. To get there, we would go spinner 1, and then we would go down 60 degrees, which is pi over 3. Or, again, polar opposite time. We want to get here, which if you think of it, if this is 60, this is 60, this little sliver here is 30, and then we got the 90, so we could spin it 90 plus 30, which is 120. I'll get to the radians in a bit, but then our spinner needs to be a -1. So if we convert that 60, that's pi over 3, goes into that twice, so it'd be -1 2 pi over 3. In other words, my spinner's 1, I spin it up 120, there's the 90 plus the 30, stop right here, but then I got to go polar opposite to right here. So this one and this one are my 2 additional polar coordinates. Good questions. Okay, number 32. Transform each of the given rectangular coordinates to polar coordinates. Remember, there's always 2. There's going to be r theta, and there's going to be -r theta. So I'm going to call this 1, I'm going to call that 2, just to indicate that there's 2 different ones. So if I draw my drawing, not a whole lot of space to do that, -3 and then up 3, and I think about this, if this side's the same as this side, then I know this little angle right in there is 45 degrees, which means this right here is 135 degrees, which is just 1, 2, 3 pi over 4s. And this would have to be 3 square root of 2, because this is a 45, 45, 90. So there's my r. So my first one would be 3 square root of 2, 135 degrees. It doesn't say to put it in radians, but I'm assuming they might. So that'd be 3 pi over 4, or just 135 degrees. Now, the other one, the -r, means we've got to try to get here. Now, a couple ways to do that, so there's more than one possibility for this. But what I'm going to do is I'm just going to say, all right, I can clearly see. Now, I could call this 315 degrees, or I could call it -45. There's no real limitations. So I'm going to go with the -45. This I'm going to turn opposite, because I'm going to go -3 square root of 2, and then -pi over 4. In other words, take a spinner, 3 square root of 2 long, go down 45, and then go polar opposite. So it'd plunk me right here. All right, let's try this one. We got the square root of 3 floating around, so we're thinking, hey, this could very likely be a 30, 60, 90. And again, not a whole lot of space, so let me get out a piece of paper, and let's draw a little bigger drawing. So 2 out here, and then 2 square root of 3, which would be a lot bigger. And we draw it in here, and we go, wait a minute, this looks like this is a 30 and this is a 60. Because remember the rule in the 30, 60, 90, you multiply that by the square root of 3. So we're like, sweet, we got it. But we need to figure out what this is by doubling this, which is 4. Basic 30, 60, 90 rules. So that means my r is 4, and my theta is 60, and that's my first answer, which 60 is pi over 3. So our first answer is 4 pi over 3. Now, how do we think about the other one? Like I said, we got to figure out the polar opposite, so that means it's way over here. And let's think about this. This is still 4, but we need to say -4, so once we get here, we have to go to the other side. Well, if this is 60, just vertical angles, back to geometry class, are congruent. So we'd say, aha, we got to spin our spinner 180 plus 60. Well, that's 240. Well, that's 60 degrees times 4, which is pi over 3 times 4, which is 4 pi over 3. So there's my negative r, there's my positive r. Two ways to get to that exact same point differently. And now this is going to be a little harder because they're not giving us fancy triangles. So you're going to have to use fancy pants math. So 3, 7. So I'd say this is 3. Got to go up 7. There's my radius or my spinner. And we need to find that thing. We also need to find this. All right. Again, we got to figure out two ways to get to that rectangular coordinate 3, 7 using polar coordinates. So there's our two options. Obviously, we got to find r. A squared plus b squared equals c squared. 49 and 9 is 58. So we know our r is the square root of 58. Now watch this. So our first one is the square root of 58, and then the question is, how far do we spin our spinner? Well, I'm going to use the opposite side, and I'm going to use the adjacent side. So I'm going to go tangent of theta is opposite over adjacent. Get out my calculator. Oh boy, it's going to do this again. Okay, give me a second. Okay, so before we even get started, second trimester pre-calc B, we're messing around with polar graphs. Make sure you change your calculator to function and pay attention to degree and radian as well. Okay, so I'm going to clear that out. I'm going to find tangent of 7/3. So second, I'm actually going to find theta. So second tangent, 7 divided by 3. Whoa! All right. What went wrong? Oh, I forgot. The second didn't take it. The second tangent, there we go. 7 divided by 3, 66.8. So that is 66.8. It says to the nearest hundredth. So, I don't know, 0.80. All right. So, now that we know, and this can get messy, we know that this is 66.8. We got to find the polar opposite. So, I'm going to erase this. I shouldn't have drawn it in there. But this is 66.8. If we subtract it from 90, that's going to help us understand what that is, and that would be 23.2. Why is that important? Well, a student might come this way with a negative spin, but I think if it's multiple choice, they're probably going to give you the positive spin to get here. So they're going to go 180 plus this, so let's go plus 180, so 246.8. So that's 246.8 degrees, but then my spinner needs to be negative square root of 58. Because if I spun it 246.8, it'd be right here, but that negative says go back, and it would plunk me right at that same rectangular spot. There's 32. 32C actually. Okay, so let's go on to this one. Now it says transform each of the polar coordinates to rectangular coordinates. So this is easier because there's only one answer. So there's only one rectangular coordinate when you're doing these problems. So my spinner is 4. I got to spin it 270 degrees. So that goes to here, and it stops. So what's the point there? That is 0, -4. There's my x, there's my y. That's just plotting that point with old school coordinate. How about this one? Well, this is the same thing as 160 degrees, and then polar opposite. So we got to be careful here. So if we go, our spinner is 1, we spin it 60 degrees, and then we come back down here. So this is 60. And this is our 1, but because it's a negative, we got to go all the way here to that spot. If that's 60, that's 60. This is still 1. So now I come here. That's 60. That's 30, 90. All right, so if this is 1, that's my hypotenuse. This little guy is half the hypotenuse. That's 1/2 or 0.5. And then what do I do to that little guy? Multiply it by the square root of 3, which is the square root of 3 over 2. But this is negative, and that's negative. So the answer to that would be negative 1/2 negative square root of 3 over 2 for that point. Okay, letter C, probably the last problem of this particular video. So my spinner's 2 units long. 5 times 30 is 150. So I got to spin it 90 plus 60, leaving me with 30 degrees, which is very important. So that's 2. Create my triangle. Never back to the y, always to the x. Half of my hypotenuse is the shorty. Multiply that by the square root of 3. And make sure you understand that's negative because it's left. This is positive because it's up. So what's that point right there? Negative square root of 3, 1. All right, you guys. So that ends this video. But we are making a lot more progress. So like and subscribe. Thanks, guys. Keep working. See me if you have any questions.